Hello everyone, this is Mrs. Figueroa, and today we're going to be going over graphing cubic functions using transformations. So our objective is students will be able to graph cubic functions using transformations. So a cubic function, we have, let me get my highlighter. So a cubic function has the standard form f of x equals ax to the third power plus bx squared plus cx plus d. And very important here, where a, b, c, and d are all real numbers, and a would not equal 0, because if a was equal to 0, then we wouldn't have an x to the third function, so then it wouldn't be a cubic function. The parent function of the family of cubic functions, so the parent function of the cubics is f of x equals x to the third power. So when we do our transformations, we're transforming the parent function for the cubics x to the third power. So you should have a copy of these guided notes. Some of my students were kind of requesting for me to kind of go over what you guys should be writing on your guided notes. So I figured I'd just do the video on the guided notes. But for the sake of time, I'm going to skip the prior knowledge. So I'm going to cross this out. I'm not going to spend time graphing the quadratic function, just for sake of time. I don't want this video to be too long. So the cubic functions has the standard form ax to the third plus bx squared plus cx plus d, and again a, b, c, and d are all real numbers and a is not equal to 0, so we have the parent function of the cubic functions is f of x equals x to the third. So our goal for today is to explore kind of what the parent function looks like so that we can learn how to transform it. So on the directions here, it says to complete the table, graph the ordered pairs, and then draw a smooth curve through the plotted points to obtain the graph of f of x equals x to the third power. And they give us a few x values to start with. So I have my x is -2, so if I go plug in f of -2, I am going to get -2 to the third power, which means -2 times -2 times -2. Excuse me. So 3 negatives is going to give me a negative, and then 2 times 2 gives me 4, and 4 times 2 is going to give me 8. So I'm going to end up with -8. So then my coordinate pair that I'm going to have is -2, -8. And then if I go plug in -1, I'm going to get -1 to the third power, which is -1 times -1 is +1, and 1 times -1 gives me -1. So my coordinate point is going to be -1, -1. And then if I plug in 0, 0 to the third power, 0 times 0 times 0 is going to be 0. And then 1 to the third power is going to just be 1. And then 2 to the third power is 2 times 2 is 4, 4 times 2 is 8. So basically all I did to fill in the table is I took these x values and I plugged them in to my function that was given, okay? So my coordinate points that I have here are 0, 0, 1, 1, and 2, 8. And to get the coordinate points, you check the x that you plugged in and the value you got out. So -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. That's how you get your coordinate points, okay? So then the directions said to complete the table. I got that part done. And then it says graph the ordered pairs. So now I'm going to take these ordered pairs over here and I need to graph them. So in order to graph them, I need to have an x-y axis. So notice I don't have an actual axis here, so you have to draw it. And I apologize, I don't have a ruler tool. Oh yes, I do actually. I have a line tool, so let me try to use my line tool. I've never used it before, so let's see how that works. Nope, that didn't do anything. Okay, I gotta learn how to use that, but I'll learn how to use it next time. All right, so please use a ruler when you guys do your x and y axis. but I'm just kind of freehanding it for now. And then remember, you always want to have an appropriate scale. My x values only go from -2 to 2, so you can skip some boxes. I'm going to go, my scale is going to be like a half, so every 2 boxes is going to be a 1. So 2 more boxes is a 2, 2 more boxes is a 3, and so forth, okay? And then you got to do the same on the other side, so -1, -2, -3, and -4. And then for my y-axis, since I need to go -8 to 8, then I'm going to just go, my scale for my y-axis is going to go by 1. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3, -4, -5, -6, all the way to -8, okay? And very important for you guys to label your graph with your scale so that we know if you're going by a half, your scale is a half, or if you're going by ones. Sometimes your numbers, like for your y's, might go from like 16 to -16, so you might have to go by 2s. So you have to specifically show us what your scale is going to be. All right, once you have your axes, then you can go plot the points. So -2, these values are your x's, and the second values are your y's. So -2 tells me I go left 2, and -8 means you go down to 8. And then -1, -1, 0, 0, 1, 1, and then 2, I'm going to go all the way up to 8. And then, so I graph my ordered pairs. Now I have to draw a smooth curve through the plotted points. I usually just graph from left to right, but as long as you graph them, then that's fine. Connect the dots, okay? And so I like to start from left side, and then I'm going to go connect it to the right. And then you always want to label your function. My function was labeled f of x. So I'm going to label my function as f of x, okay? So this is the parent function for the cubic functions, okay? So if you notice here, when graphing f of x equals a times x minus h to the third power plus k using transformations of the parent function f of x equals x to the third, we consider the effect of the transformations on the 5 reference points, -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. So everything that we're going to do with cubic functions, we're going to be transforming using those 5 key points, okay? And then we're gonna have to know what your a, h, and k is, and hopefully you practiced that on yesterday's lesson or on the previous lesson. So if we look at the first example here, it says graph using transformations g of x equals x minus 3 to the third power minus 1. So in order to do transformations, we're gonna have to build a table. And we're going to have to transform our x values and our y values. So to every x, we're going to go add h. And then for every y value, we're going to have to multiply by a. So a times y. And then we're going to go add k. So these are your transformations. For your x's, you want to add h. And then for your y values, you want to multiply by a and add k. So your g of x coordinates are going to have those new points. So then I'm going to go calculate these, and this is going to be my x and g of x at the end, okay? So my key coordinate points that I just had up here, -2, -8, -1, -1, 0, 0, 1, 1, 2, 8, those are the ones I want to put under my x and my y's. So my first coordinate is -2, -8, then I have -1, -1, 0, 0, 1, 1, and 2, 8. So next I need to know what are your h, a, and k values. So from yesterday's lesson, I keep saying yesterday's lesson, but the previous lesson, you should have had the g of x equals a oops, I have a in red, so a times x minus h to the third power plus k. So if you notice, your a value is in front of your x, so I don't have anything in front, so that tells me that my a value is going to be 1. And then to calculate your h, it has to be the opposite of h, so the opposite of -3 is going to be a +3. And then your k value, k is after your cube, so after the cube at the end, that's your k. So after the cubed here, I have a -1 for my k value, okay? So for my h value is going to be 3, so I'm going to go add 3 to all of my h's. And then for my y's, I'm going to go multiply by a, which is 1. And then I'm going to go add k, which is -1. Okay, and then you can go calculate these using mental math. So -2 plus 3 is going to give you 1. -1 plus 3 is going to give you 2. 0 plus 3 is 3, 1 plus 3 is 4, 2 plus 3 is 5. And then your g of x value is going to be 1 times -8 is -8 minus 1 is -9. And then 1 times -1 is -1 minus 1 is -2. 0 times 0 minus 1 is going to be -1. 1 times 1 is 1. 1 minus 1 is 0. Oops, sorry. And then 1 times 8 is 8. 8 minus 1 gives you 7. So then you have to go, again, draw your scale. So I'm going to pause the video for a second. I'm going to go draw my scale because it takes me a little bit. And then I'll be back. Alright, so notice I moved my y-axis further to the left because I noticed on my x values I had to go from 1 to 5. I didn't have any negative values, so I just need the right side of the graph. So I moved my y-axis over to the left, and then the x-axis I left it sort of in the middle just because I have to go from -9 to +7. So it was like kind of evenly distributed, so I just left it in the middle. Okay, so then you have to go graph this 1, -9. So we're going to go right 1, down 9, and then 2, -2, right 2, down 2, and then 3, -1, 4, 0, and then 5 up to 7, and then you have to just go draw the curve. And then don't forget to label. So this is going to be g of x, okay? So if we think about the parent function, my parent function, which I kind of wish we did have you guys compare it, but your parent function kind of looks somewhere over here where you have, it's not drawn to scale because I kind of just drew it really fast, but I guess I could draw it to scale. So remember, we have your parent function -2, -8, -1, -1, 0, 0, 1, 1. Oops, it's still not drawn to scale because I forgot about my axes. Is going by a 0.5 instead of a 1. But anyway, so this is somewhere over here is my parent function. So my g of x function, I noticed it went to the left. Sorry, to the right. It went to the right, and it would have gone to the right 3 because that was on the previous lesson. You should notice h is +3, so it went to the right 3 times, and then it stayed on the, it went down. Notice my middle point, and my middle point is down here, so it went down 1. And I can tell it went down 1 because that is my k value is a -1. And then there is no a value, so there was no stretch or compression. So you can see that the, oh no, I erased my axes. But I was trying to say that there was no stretch or compression. And you can tell because the function still kind of looks like the parent function. Okay? Which you don't have to go describe left, right, up, down, stretch, compression. I was just trying to get you guys to see what that looks like. All right, so in our next example, we have h of x equals -2 times x to the third power. So we're going to have to figure out what a, h, and k are. So if you remember the transformation function, g of x is equal to a times x minus h to the third power plus k. Okay, so if I look at this function, I have to go figure out what your a, h, and k are. So a is in the beginning, your coefficient is -2 in this case, so my a value is -2. And then your h, notice h is next to the, it's in between the x and your cubed, and you have like the opposite sign. But in this example, my x is right next to the cubed. I don't have anything in between the x and the cubed, so this tells me my h value is going to be 0. And then your k value is at the end. There's nothing after the cubic, so your k is also going to be 0. So when we do our table, you have to remember what you do to the x's, and then what do you do to the y's. So remember, x, you're going to go add h, and then to the y's, you're going to multiply by a, and you're going to go add k. And then once you get your new coordinates, once you get your new coordinates, you have to label them as x, and then this one is h of x. Okay, so remember your key coordinate points for the parent function are -2, -8. So I'm putting those under my x in black and my y's, okay? Then I have -1, -1, 0, 0, 1, 1, and 2, 8. And then I am going to go add h to all my x's, which is 0. And then I'm going to go multiply my y's by a, which is -2. And then I'm going to go add k, which is 0. And then you calculate your coordinate points. So notice I'm adding 0 to my h's, which is really nothing. So I'm going to stay with -2, -1, 0, 1, 2. But for my y's, the only thing basically I'm doing is multiplying by -2. So -2 times -8 is going to give you +16. -2 times -1 is +2. Anything times 0 is 0. -2 times 1 is -2. And then -2 times 8 is -16. So then you have to think about where do you want your x and y axis to go on your graph. It's going from -2 to 2, so it's evenly distributed, so I can put my y axis right in the middle. Or close to the middle as possible, so it cuts the x-axis in half. And then my hx, which is the y-axis, is going from 16 to -16, so again, evenly distributed. So I'm going to put my x-axis in the middle, so it cuts the y-axis in half, and it makes it evenly distributed, okay? So then I can just go from -2 to 2, so, oops, I put 2, but I'm gonna go by 0.5 for my x's, -1, -2. But for my y-axis, I need to go all the way to 16 and -16. If I go by ones, I'm not going to have enough space, so that tells me I have to go by twos. So my scale is going to go by 2. So that's 2, 4, 6, 8, 10, 12, 14, 16. And then I got to go to -16. 2, 4, 6, 8... -10, -12, and -16. And then you have to go plot these. So -2, left 2, and then I'm going to go up to +16, and then left 1 up to 2, 0, 0, and then right 1 down to 2, and then 2 down to -16, and then I'm going to go draw my curve. I apologize. My graphs look like they look horrible on here, but I try my best. Okay, and then again, label my function is called h of x. All right, for our last example, it says 2, but I want to change this to a 0.5, just because I want to show you guys an example of a vertical compression to see what it looks like. I forgot to mention it, but in this example, it would be a vertical stretch because my a value is -2. So it's going to be stretching it. Notice my y-axis went from 16 to -16. But I want to show you guys what a vertical compression would look like. So let's look at your a, h, and k. A in this example would be a 0.5. My h value is between my x and my cubed, so it's a -1. Remember, you have to do the opposite of h, so it's going to be a +1. And then your k value is going to be at the end is -1. Okay? So if I make my table, x plus h, a times y plus k, I'm going to go plug in my values. So my parent function is -2, -8, -1, -1, 0, 0, 0, 0, 1, 1, 2, 8. I'm going to go add h to all my x's, so +1. And then I'm going to multiply by a, which is a 0.5, which 0.5 is the same as a half. And then my k value is -1. And I'm going to go calculate those again to get my x and, x and g of x. Okay, so -2 plus 1 is going to give you -1. And then I'm going to get 0, 1, 2, 3. And you can check my math. I'm just kind of trying to get this done so I don't take too much on the video. So -8 times 0.5 is the same thing as -8 times 1/2, which is divided by 2. So -8 divided by 2 is giving you -4, minus 1 is -5. And then 0.5 times -1 is going to be -0.5, minus 1 is -1.5. Anything times 0 is 0, minus 1 is -1. 0.5 minus 1 is going to be -0.5. And then 0.5 times 8 is 4 minus 1 gives you 3. Let's go draw our scale. I need to go from -1 to 3, so I can shift it a little bit over to the left because I have more positives than negatives. And then I need -5 to 3. I can put that one close to the middle. And then you can, I like going by 0.5 for my x's just because they're spread out less than the y's. So 1, 2, 3, and -1. Oops, I didn't. Oh my god, sorry. -1, and this would be -2. So every 2 boxes is 1 because my scale is a 0.5. And then I can just go by 1s. I can even go by 2s on this one also. Every 2 boxes is a 1. So this is 1, 2, 3, 4, 5, -1, -2, -3, -4, and -5. So you can make your scale as big or small as you would like. You just need to tell us what your scale is going to be. Okay, so my x again is -1, and I'm going to go down to -5, and then 0. I'm going to go to -1.5, so -1, and then half a box more is -1.5. Oops. Come on, Miss Figueroa. I switched my x and my y on that one. Sorry, guys. Hopefully you're paying attention. It's 0 stays on the y-axis. stays on the x-axis, and then I'm going to go down to -1 and a 0.5. Oh my god, this is purple. Okay, and then 1 to -1, and then 2, I'm going to go down to -0.5, and then 3, I'm going to go up to 3, and then draw your smooth curve, and label this one is a g of x function. That's what this is called, g of x. Okay, so notice this is a vertical compression. You can tell because my y-axis went from a +3 to a -5, so it's smaller than like your +8 and your -8 in your parent function. Like your parent function is -8, +8, and then the transformed one only goes from 3 to -5, so it's smaller than the previous one. Then the parent function, you just can't really tell because my scale is zoomed in, kind of, because I'm going every 2 boxes is a 1, my scale is a 0.5. Okay, and that was our last example. So if you guys have any questions, feel free to reach out to one of your teachers. Thank you guys for watching.